Hey, what's up, everybody? I hope that you guys are doing well and that you are staying safe and staying healthy and that your families are doing well. I wanted to post a quick video on probability of a compound event. And we've talked about this some in class, but I thought I'd put a quick video out there just to review the concept so it's a little bit more fresh. And the first scenario we'll start with, which is kind of familiar, is Mr. Foster has a fair-sided coin and a number cube. He is going to flip the coin and then roll the number cube. What is the probability that the coin will land on heads and the number cube will land on an odd number? So we've got the coin and the number cube. The coin, of course, could be any kind of a coin. In this case, I've got a quarter in there. And then a number cube is going to be a die, like you'd have if you were playing a game. And the word problem will always say number cube, so we don't want that to confuse us. And we're talking about probability of a compound event. We're talking about the probability of more than one event occurring. So when we solve for probability of compound event, we need the probability of the first event, the probability of the second event. We multiply them, and then we make sure our answer is simplified. So when we look at this, it says the first event is what is the probability that the coin will land on heads. And then the second event is, and the number cube will land on an odd number. So let's get the probability of the first event. So what is the probability that the coin will land on heads? Well, really, there's only two sides to a coin. And in this case, heads is only on one of those sides. The other would have tails. So there's a 1 out of 2, a 1/2 probability that this coin would land on heads. For our second probability, we're going to look at the number cube. And what is the probability that the number cube will land on an odd number? Well, this is a traditional number cube, traditional die, so it's got 6 sides. And how many of those sides have an odd number? When we think about it, 1 is an odd number, 3 is an odd number, 5 is an odd number, and those are going to be the 3 odd numbers that you would have on a traditional number cube or a die. So 3 out of 6. So now we have the probability of our first event, we have the probability of our second event. All we need to do now is multiply, make sure our answer is simplified, and we should be good to go. You can simplify this before multiplying, which I'll show you in just a second, and that will usually reduce the amount of simplifying you have to do at the end. But we're going to do this way first, and then I'll go over that. So straight multiplication with fractions here, we're going to multiply the numerators, multiply the denominators. 1 times 3 at the top is 3. 2 times 6 at the bottom is 12. 3 out of 12 is pretty close to the answer, but it's not simplified. We want to simplify this fraction, and 3 can go into both itself, 3 and 12. So 3 goes into itself 1 time, 3 goes into 12 4 times. So it looks like the probability is a 1/4 probability. Now, I told you just a second ago you can actually simplify beforehand sometimes, and that makes your answer at the end, I guess, a little faster, and your multiplication can be a little easier. So let me back up, and I'll show you that method as well. So there we multiplied, and then we simplified. If we want to simplify first, we look at any of these fractions or these probabilities that can be simplified. 1/2 cannot be simplified. It's already simplified to its lowest form. We're good there. 3/6 can be simplified. 3/6 really is the same as, sorry, let me wipe this out, is the same as 1/2. 3 goes into itself 1 time, 3 goes into 6 2 times. So that can simplify to 1/2. And then when I multiply at the top, 1 times 1 equals 1, 2 times 2 equals 4, and we get the same answer, 1 out of 4, but I don't have to simplify at the end. So the probability of me flipping a coin, landing on heads, and then rolling that die, landing on an odd number, is 1 out of 4. Let's check out this probability. It says Lizzie has a bag with an assortment of marbles. Lizzie's going to select marbles without looking. What is the probability that Lizzie randomly selects a green marble, does not replace it, and then selects a yellow marble? All right, so we're going to use the same method. We need the probability of the first event, probability of the second event, and then we just multiply and simplify. So when we look at the first event, probability of the first event, what is the probability that Lizzie randomly selects a green marble? Well, how many marbles total do we have in the bag to start with? We need like our total. We've got 4 rows of 3 there. It looks like there are 12 total marbles in that bag, and 2 of them are green. I'm going to leave it like that. We can simplify that, but I'm going to leave it like that for now. That's the probability of the first event. We then need the probability of the second event. And there's some important information in the word problem that will help us determine that probability. It says Lizzie's going to randomly select a green marble. She does not replace it. So that means she takes the green marble out and does not replace it, kind of like you'd have this situation. So now how many marbles are in the bag? If she does not replace it, we lost one of them, so now there's 11 marbles in that bag. Then selects a yellow marble. So how many are yellow? 1, 2, 3. So our second probability, that's what I need to read carefully, actually goes down to a 3 out of 11 on that after she takes one out and does not replace it. So I've got my probabilities. I can multiply and then simplify, or you could simplify before and then multiply, whichever you're most comfortable with. I'm going to leave it like this. I'll do it both ways, but if I leave it like this, 2 times 3 at the top is 6. 12 times 11 at the bottom is 132. When you simplify this down, 6 does go evenly into itself, and 6 also goes into 132. 6 goes into itself one time and goes into 132. I believe it's 22 times. So 1 out of 22 is the answer there. If I did this the way where we simplified first, I could take 2 out of 12, simplify that to 1 over 6. I simplified that using 2, dividing by 2. 2 goes into itself one time. 2 goes into 12 6 times. And then I can multiply that by 3/11 is already simplified. There's nothing you can do to simplify that any lower. And then we multiply. 1 times 3 is 3. 6 times 11 is 66. I have a lower probability. I have kind of a reduced fraction in a sense, but it's not reduced to its simplest form. This 3 over 66 can still be simplified. And by 3. 3 goes into itself. 3 goes into 66. 3 goes into itself one time. 3 goes into 66 22 times. And so you'll see I got the same answer. The probability that Lizzie's going to have of selecting the green marble, not replacing it, and then selecting a yellow marble is going to be 1 out of 22. Last one, I wanted to pick kind of an assessment question just so you see what they look like. And it says, Gabriel has these cans of soup in his kitchen. You've got this selection of cans that he has probably in his pantry. Gabriel will randomly choose one can of soup. Then he will put it back and randomly choose another can of soup. What is the probability that he will choose a can of tomato soup than a can of cheese soup? So this question is similar to this question with the marbles. There's a slight difference, and we'll talk about it in a second, but we know we need the probability of the first event, the probability of the second event, and then we multiply. The first thing we want to do is total up, like how many cans of soup does Gabriel have here in his pantry or in his kitchen? So we add all these up. I've got 2, 3, 2, 2, and 1. It looks like he's got 2 and 3 is 5. Right over there, and then 2, 2, and 1 there is another 5. It looks like he's got 10 total cans of soup. So out of 10, the first probability, it says he will randomly choose one can of soup. He will put it back and then randomly choose the other can of soup. So since Gabriel's going to put the can of soup back, he is going to actually replace it this time. He's not going to leave it out. Both probabilities will be out of 10 because there's going to be 10 cans of soup. So what is the probability that we'll choose a can of tomato soup? Let's do the first event. So tomato soup. How many cans of tomato soup do we have? Cans of tomato soup is right here. Looks like he's got 2 cans of tomato soup. And then it says he's going to put it back, so we'll still have 10. And then how many of cheese soup? Cheese soup, all right. Looks like, again, 2 cans of cheese soup, just like that. Now, 2 out of 10 times 2 out of 10. I'm actually just going to write these a little bit smaller. Sorry, guys, because I can simplify. So 2 out of 10 times 2 out of 10. Now, I can multiply and then simplify if we want. When you multiply across, 2 times 2 is 4. 10 times 10 is 100. When you simplify 4 over 100, which needs to be simplified, 4 goes into itself one time. 4 goes into 125 times, and there's a 1 out of 25 chance. I could also simplify these now. 2/10 is the same as 1/5. It's the same as 1/5 on this other 2/10, and when you multiply, 1 times 1 is 1, 5 times 5 is 25. So Gabriel's probability here of selecting a can of tomato soup, replacing it, and then getting a can of cheese soup is going to be 1 out of 25. So that wraps it up for a quick little video on probability of compound events. Got a couple of questions up too that you can practice, but I hope you guys are staying safe and taking care. I'll be talking to you soon. Thanks.